Well, thank you so much. Today's Today is examination or today's classification geodescis. Geodescis. G-E-O Geodescis. Geodescis. Geodescis means প্রভুভিত্তিক। জিওডেসিস means প্রভুভিত্তিক। প্রভুভিত্তিক in dimensional space P0 and P1 and any two points on the card XR equal to XR T. We have matrix tensor ds square is equal g of ij dxi dxj and arc length between 2 points at the given curve is S equal T0 to T1 Gij dxi divide dt and dxj divide dt root over dt. It's also memorize the geodescis of point P0 and P1. It passes through the curve. Which is the P0 and P1. P0 and P1 measured along the curve is stationary points. Okay. This called which is called the geodescis. Clear? Again, in n-dimensional array space, the point P0 and P1 are any 2 points on the curve XR to XR. You have to thinking this is the curve with R space of the points P1, P0 and P1 is the space, is the dimensional space, means n dimensional space. N dimensional space is R space of the 2 points P0 and P1 whose the curves XR and XRT. Now we have matrix tensor ds square dij equal dxi dxa. At the length between the 2 points is given the curves is equal to f2, where P0 and P1 measured along the curves is the stationary point, which is called the geodescis. Geodescis means probabilistic. You see, it is called geodescis. That the geodescis, and somehow are rules, somehow are follow to rules, and the somehow are follow the 2 rules. That's the d square xi divide ds square plus I j k is the dxj divide ds into dx k divide ds equal 0 is the divide 0 is the Riemann space. Geodescis is the found from the differential. It is differential equation. It is differential equation of the geodescis space of the geodescis space. It is the differential equation of the geodescis space, and it is the which is where R is the arc length, where R is the arc length parameter. Okay, these geodescis on a plane are straight lines, and geodescis on a sphere are arcs of the great circle. It's also rules. Geodescis is followed to rules. Firstly, in n-dimensional R space, 2 points P1, P0 and P1, and then the curve are XR equal to XRT. Who is the following this format and rules? It is differential equation of the geodescis space, where S is the arc length of parameter. Okay, and Euler's or Lagrange equation, and it follows this Euler's equation, and this follow with Euler's equation. The equation dA by del A by del xk minus d by dt del f divided by del x dot k equal 0. It's follow the Euler's equation. One kind of Euler's equations. It is one kinds of Euler equation. It is one kind of Euler equation. Thus, this dimensional space to follow this and this rules. Obviously, we have to thinking geodescis must be question with in future answer. Answer this note now in your examining hall. It is 100% important. 100% important. So, in n-dimensional R space P0 and P1 are any 2 points on the space curve XR equal to XRT. That's rules, and follow that rule. This is the geodescis formula, and it follows these rules or equation. Okay, thank you. I think firstly show that, prove that theorem 40 is so important, and mind these rules. It is followed to rules. So that I equal to integration T1 to T2 above T x and x dot dt will be maximum and minimum, extreme or maximum and minimum value. Well, maximum minimum value, then if and only if and only del f by del x minus d by dt into del f by del x dot is a 0. It's so important with this fountain exam. Maximum students are called to me, sir, this theorem is important or not. I think this theorem is so important, and you have to practice in your home. Obviously, firstly you have to memorize I equal integration T1 to T2 f of T x and x dot dt is number 1. The curve which makes I an extremum value, let x plus x of t, whereas t is less than t2. Well, then there exist a neighborhood curves. Then there exists a neighborhood neighboring curve at T and T1 and T2. Neighboring curve pass T1 and T2. Then x equals to xt plus eta n of t is a number 2, whereas eta t1 and eta t2 is a 0. Then epsilon is not epsilon of t, is a number 2 and is a number 3. So one implies I of eta is equal T1 to T2 f of t, right, x plus x of t, comma x plus x of t means t x plus eta tau comma x dot plus n dot t right. Okay, is that number 4. Then number 4. Now epsilon is equal 0. Then 1 is eta will be extremum at q equal 0. The necessary condition is that then by necessary conditions is that di by d of epsilon t goes to 0 equal 0. Is a number 5. Well, again di by d of epsilon equal to t1 to t2 del by del epsilon f of t comma x plus epsilon of tau epsilon eta or tau x dot plus epsilon n dot dt. Clear? Again t1 to t2 just for derivative with this formula del f by del of x into del by del of epsilon x plus epsilon of n plus del f by del of x dot into del by del epsilon into x dot plus epsilon into n dot. Whole of terms is a dt. Okay. Now t1 to t2 is a del of f divided by del of x to eta plus del of f divided by del of x dot into tau of dot into dt using that's a 0. It's a from 5. Now that implies t1 to t2 del f by del x into tau plus del f by del x dot into tau dot into dt equal 0. Again that implies t1 to t2 is a del f by del of x and tau plus del f by del x dot into eta of t. Eta of t is a t1 to t2 minus t1 to t2 is a n অর্থাৎ tau del f by del x dot into dt equal to 0. Well, that implies integration t1 and t2 to t2, whereas all of common is eta df by del f by del x minus del by del t into del f by del x dot whole of bracket equal 0 is a using 3, right? Okay, last is theorem is that implies it's a derivative, then limit is cut, then obviously del f by del x minus del by del t into del f by del x dot equal 0. It's the number 6. So it is which is the n dimensional Riemann space. Which is the n-dimensional Riemann space, and one implies I equal integration t1 to t2 is a f of t, right, and x1, right, and x dot 1, right, and x dot 2, right, that's xn, right, or x dot n, right, bracket in dt. Well, actually this is the main formula. Well, and 6 implies means del f by del xk minus d by dt into del f by del x dot k equal 0. Well, whereas k equal to 1, 2, 3 up to dot n, which is known as the Euler's differential equation, which is known as the Euler's differential equation. Differential equation of geodescis Riemann space. Which is the geodescis Riemann space, which is the Euler's differential, which is known as the Euler differential equation, which is known as the Euler differential equation of geodescis Riemann space. Well, it's a main formula, and we have to clear this formula. It's so in front of the exam, and so important this theorem. this theorem, I think this theorem is so easiest, and mainly your format, mainly this format are proved, mainly this format are proved is geodescis. Well, you and your friends are so likable this formula. This formula is so easiest method, and you have to clear, and you or your friends are examining in hall is the easiest process. So well, actually you are watching this video in totally, and you and your friends are subscribe and share with this video. This video is totally completed watching this video. Then mentality and examining hall are so easiest. I think you are collecting total marks, and it's a finally and last format, last formula. Then you have to advance in next class. Well, thank you.